Hey everyone! In this video we're going to be doing another related rates example, but in this example we're going to be using triangles, and specifically we need to use the Pythagorean theorem. So my example says the top of a 13-foot ladder is sliding down a vertical wall at a constant rate of 1 foot per minute. What is the rate of change of the distance between the bottom of the ladder and the wall when the top of the ladder is 12 feet from the ground? So again, just as a reminder, related rates are rates of change that are directly tied to each other. The two rates of change I have in this problem are the top of the ladder sliding down the wall and the bottom of the ladder moving away from the wall. And we can think about how fast each of those is happening. And it makes sense that they are related to each other. Because the ladder is a fixed length, as the top of the ladder moves down the wall, the bottom of the ladder has to move away from the wall to make up for that difference. So to start, let's just draw a diagram and we can think about what we know in this problem. So we have a wall and the ladder is leaning up against this wall. So this can be represented with a right triangle. I know that the ladder is 13 feet long, and then my two sides here, I'm going to label this as X and Y. So X here because that's horizontal, and I'm going to label that one as Y because it's vertical. And we have a right triangle. Now, one of the first things we do when thinking about related rate problems is we need to use an equation that relates our variables together. So my two variables here, I have X and I have Y. The height of the ladder on the wall and the distance away from the wall or the bottom of the ladder. So to relate these two together, we can use the Pythagorean theorem. So the Pythagorean theorem, we have x squared plus y squared is equal to 13 squared. So that's the equation we're going to use to relate our variables together. Now let's also think about our rates of change and what else we know. So we are given that the top of the ladder is sliding down the wall at a rate of 1 foot per minute. So the top of the ladder is moving down the wall at 1 foot per minute. So that rate of change, that is our change of y with respect to time. So the derivative of y with respect to time, because it's moving down the wall, we're going to express that as -1 foot per minute. What we want to find is we want to find how fast x is moving away from the wall. So we want to find the rate of change here. So what we're looking for is dx over dt. And then the last thing we're given is that the top of the ladder is going to be 12 feet from the ground. So we know that y is going to be equal to 12. If y is equal to 12, that also means that x is going to have to be 5, which we can find using the Pythagorean theorem. So if x squared plus 12 squared is equal to 13 squared, we can quickly solve this to see that x has to be 5. So that's 144, 169, so x squared is equal to 25, and x has to be 5. So we also know that y is equal to 12, and we know x is equal to 5. So it's a lot of information we know. So the rate of change for y is -1 feet per minute. We want to find the rate of change for x. We know x is 5, we know y is 12, we know that the ladder is 13 feet. Now we can solve our problem. So going back to our Pythagorean theorem, our equation that's relating together x and y, we're going to start off by finding the derivative of this. So we're going to take the derivative with respect to time. So the derivative of x squared is 2x, and then this is multiplied by dx over dt. The derivative of x with respect to time. The derivative of y squared, we get 2y times dy over dx. And on the other side of the equal sign, the derivative, this is just a constant, so the derivative of that is just 0. So now we have an equation that's relating together our rate of change. So let's plug in what we know, and we should be able to find our rate of change for x. So we know x is 5, so we have 2 times 5 times dx over dt. We know y is 12, so we have 2 times 12. And then the rate of change for y, we know that's -1, and this is still equal to 0. So we have 10 dx over dt. 2 times 12 times -1 is -24. And just to finish solving this, we have 10 dx over dt is equal to 24, and dividing both sides by 10, the rate of change for x is equal to 2.4 feet per minute. So here's our solution. So what this means is because the top of the ladder is moving down the wall at 1 foot per minute, -1 feet per minute, at the moment that the ladder is 12 feet from the ground, the bottom of the ladder is moving away from the wall at a rate of 2.4 feet per minute. And again, related rates, rates of change that are directly tied to each other. And in this case, the rates were the top of the ladder moving down, the bottom of the ladder moving away. In the process we used here, we came up with an equation, in this case the Pythagorean theorem, that directly related our two variables together. We identified what we knew, we took a look at the derivative, plugged in our information, and we were able to solve for that unknown rate of change.